Welcome again to the second 10 dual pole motor Energizer kit presentation for the new setup, horizontal setup here in the aluminum plates, aluminum rotors. And today we're going to try and hook this up to 48 volts. And I haven't touched this at all. The batteries are stabilized from my last video to 25.4 and 25.58. So this is what were to be expected. Batteries both came back up. This one came back up and this one came back down. And we saw the voltages prior to that. However, they had been running for a little bit of time before that. So they went quite stabilized when we started the last video as they have today. Now it's been couple of days, so today is Tuesday. I have to look when I last made the video, but it's been over the weekend, I guess Friday. So we have a couple of days here, and the batteries are still standing at above what we normally consider fully charged, so that is good. And now what we're going to do, yes, is hook up these batteries as well. These are brand new. For the most part, one of them is over there is a little bit older, on the 10th month. These, however, are from February 2015. Costco Interstate batteries. Not the best batteries, but the best for the price, I would say. So we're going to hook these back up right now. As soon as I can find some connectors here, and we will run at 48 volts now. Alright, here we're back again. Now it's all hooked up. Batteries turned around. 48 volts. This is the charging battery right now. It's 50.3. And this one is really sitting at 51. I just ran it for a little bit and it's still coming back. And that's that one right there, that bank. And so we've got the amp meter hooked up. And we've got a bunch of LEDs again hooked up. These are 100-watt LEDs. That takes 100 watts to light up full brightness, each one of these. Little critters here. So what we have is these 5 are in series. 1, 2, 3, 4, 5. These 5 are in series, these 5 are in series, and then they're reversed. So now again, we're not using the right thickness of wires here for this kind of setup, but we're running this very lightly here. And again, you want to hear the thump if I have that disconnected and I connect the primary battery. You'll hear it go thump to make sure that everything's running correctly. So let's give it a spin. So you can see already the pulsing on that is, we're already at 27 volts. This is just 1/2 of the generator coils. As we know, this side so we don't want to go too much above this point for that, because we don't want to blow out these LEDs. So we got to get up to voltage here before these will really start coming on. So of course we're only pushing 2 amps right now. It's not really pushing, it's tickling. So we don't have like a suitable load on these generator coils for this. It's interesting to see. See, this rotor has some crazy glue making it imbalanced, and that needs to be machined off the surface, which we'll do in the future. But for testing purposes, we're just showing this. We're going to show at the end of this video the other rotor on here. So you can see it charges, everything's good, 48 volts. And we're going to get up to speed here, up to voltage. So if we disconnect some of these, so you can see that turned off those. So you probably put one on one side and one on the other. So we can push this a lot faster again. But right now we're just showing you the basics, the very, very basics. So we wanted to charge up these batteries. These haven't been charged that much. They haven't been really cycled very much, so they're still in the conditioning process. So we're 4 amps, it's nothing. Of course we're all going to be very cold here. Well, except for this pot here, we're going to have to replace that pot with a different set of resistors here. What we can do is run the light, or the pot through the light, and then go from there. So we can go like this, so we don't put now we only have 2 amps, so see this light is nice and bright. It's not quite the right resistors that we need to have here, but we're just showing the preliminary setup. We'll get this set up with the other rotor a little bit later. I just wanted to run it, basic test here. There, let's get above that. Don't want to push it too fast. What we want to do is get the right resistances figured out here and then switch between them instead of using this pot, because so we can see this is getting warm, so this is running at pretty much almost full brightness. It's blinding my eyes, I can't even see into it. And it's got the heat sink, so you know the heat on there is with the sink itself. And this pot now is cooler, which is what we want. We want to make sure transistors, of course, they're not hardly being used at all. We could be running off of 1 transistor right now. We could easily do 3 amps, 1 transistor, but we have 80 transistors here to deal with, so just giving you a feel for that. I don't want to load, I don't want to run this too fast without a load on there. We need to have really a load on the other side. I don't want to put this on here yet because I don't want to blow that out. But we'll run some other loads later on here, and then we'll run the other rotor on here. That should be a little more balanced. So there we have 53 volts already on the charging battery, under charge of course, and then 49 volts. So this is going to keep going up to speed, going faster and faster. It's got a long way to go to really get up to full speed on 48 volts. It's just crazy how fast it will go. So, but anyway, we got these bulbs going here, 135 volts, so they're not running very hard at all. They still are getting warm a bit. You can see, at least on when I'm looking at the video here, the flickering is taking place. So I suppose what we could do is run half of those bulbs on one side and half on the other, and then have more of a load there, or we can run other loads. So should be good. Don't want to push this all too hard because we're already at probably maximum with this light. And that's pot too. We're really pushing things here. So we're almost at 5 amps, 4.5 amps here. Really cruising. So without these bulbs on, I can show you the, as you see here, disconnect the bulbs for a minute. See, we're at 249. So you can hear the motor speeding up because this was a little bit of a load. And of course, amp draw is still the same. So the amp drop, or the voltage drop on here, according to the, so you can remember from the last video when we did some of this, I think the second last video actually, when we were running at 48 or 24 volts on the 4-pole. We were doing that. So again, you can see even with very, like, running this at like, let's see, maybe almost 1/50th of the power potential, you know, we're still charging the batteries really good. And the reason why I don't want to push it too hard is because these batteries are really not big enough for the potential of this motor. I just wanted to show that it can run at 48 volts and show what's happening when we're really just tickling it. Now we can run it with the opto switch as well, and that will give us a whole different output. We don't have to. We can almost self-start it. Just have to move it into position. It will self-start. But so you can see now the primary battery is, you know, it's sitting at 49 just comfortably there, and it will probably just stay there for a while because I have fairly little amp draw. So, and then some of the primary battery gets a little charge back to itself. So there is an ideal sweet spot in that as well. Where when you have a really charged battery, as we have here, 54.8 volts now, then the charge doesn't have anywhere to go really, so it wants to go back somewhere. It goes back into the charging battery. I mean, that's one way of looking at it, I guess. But we don't want to leave it at this. We want to really discharge these batteries and charge them up from a lower voltage point here, and remain in the you can go right down to zero capacity, but you want to go up to maybe 85-90% and make that your working capacity. When I would say 90% would be a 12-volt battery, 12.6, when you consider a Renaissance type of charge, is full charge is higher than the regular charging. So anyway, we're good here with, the only thing I want to monitor is So you can see we're not even touching these transistors. They're essentially a little over room temperature. Same with the diodes and the. So we want to look here. We can see the SCR and diode is all good. The motor coils are all good. So you can see this LED is on fairly bright based on the heat that's being produced. 100. This heat sink itself is at 100. Hold on. Yeah, somewhere in there is 120 Fahrenheit already. At least this pot is not so hot right now. Oh, it's kind of hot. So again, we don't want to push it. Of course, I need to put different wires on here to finalize it. The ladybugs love this this energy too. So yeah, I mean it's still charged there, and all is good. I want to be very careful how I turn this down, and that's why you want a bulb in series with it, so it doesn't push it too hard. So now I just turned it up a little bit, and we're almost again 5+ amps. It's really cruising now. So under load, so these are getting fairly bright right now. So we're only at like 250 watts, but this bulb alone, like I said, is drawing what would be considered 100 watts worth of light it's producing at that temperature. Just want to make sure all the temperatures, and then of course you can measure the light intensity. It's kind of hard because it's very, very bright light. You have to measure it carefully on the surface at a given distance. So yeah, again, you can see almost 57 volts. I don't want to push this too much harder. Only 5 amps now, and it would be interesting to check the RPM on this right now, but I'll do that later on. I could put a sticker on there. So yeah, there we have it. Well, it's much to say beyond this right now. So again, we could turn it off and see it slow down again. So of course the lights went off, and these are going to slowly go down. You can see it is not based upon the motor connection there. It's purely separated and related to the RPM. So these will slowly come down. So what we'll do is, I think we're going to switch the rotors right now and put half of these LEDs on one side, half on the other, and get this kind of connected up a little more stable here, and see what we have. So you can see already the primary battery is bouncing back up, and it will probably stabilize around 1 or just 50.9 or something like that, and then the charging battery will be higher than it was when we started. So we'll come back in a couple hours and see where it'll be dark then, so you can see the lights at night. All right, we're back here with the other rotors changed over. You can see, I'm going to put these rotors. These are the normal rotors with a little bit weaker magnets. And then we've connected up the 100-watt LED modules here and here. So the wires, and we've got the voltmeter down there. Cleaned up the wires a little bit. Yeah, it's still a mess of wires. It looks like I had the amp meter on the charging battery, not on the input battery, the last segment. But you can see the batteries have come back to, again, a similar position as I said, 50.9 and then 50.4. So now we're going to run this here. We've got a variety of resistors here. These are 4 ohm coming off of each group of the trigger wires here. You can see coming out here. The red one and the black one coming to those 5. And so what we want to do is call these branch resistors. And then it's going into the pot and the bulb in series. So what we can use is this high halogen bulb or some of these other resistors. I've got a whole bunch of them right here. So right now we're going to turn this pot up. I just ran it for 1 second there and confirm it was working. So let's turn it down a little bit more. Oh. So you can see it's pretty high. You can see the amps, only 2 amps. So we're probably going to go down. This is extremely bright right now. May end up blowing out one of those bulbs, and I might need to run the halogen bulb, and I might need to bypass these resistors here. We'll see. So let's try the halogen bulb here. If I can get in there, hold it in my hand. So you can see that it's a different kind of load here. Of course, I'm pushing quite a bit more amps there. So I'm just going to go up for starts. So we can see we are already 182 volts. So it depends on the kind of load, like I said, we're running here. We can run this one in series or in parallel maybe with the overall load. You know, it depends what you want to do. You can see we're charging pretty quickly again. Now this table is a little bit soft, so it's not really holding the weight very well. I'm going to get this thing up to a higher speed. So at the lower RPMs, there's more of a vibration because of the magnets are pretty close together, so they're really pulling tight. But once it gets up to that speed, then they freely float, which is a problem. I mean, it's not going to run it normally that low. See, now I'm too hot on this pot. So what I need to do now is switch over It looks like I'm about 20 ohms there, so I'm going to go and grab, I've got all these sets of resistors here. Instead of putting too much on this, pot, I want to be able to just use that. See? This pot was pretty hot, rheostat. Then we could maybe go down to, like, we want to switch between these until it gets up to speed, and then we want to drop down, perhaps. So you can have a variety of resistors here to play around with. Again, you can see the amperage, the charging rate. We're at 55, almost 55 volts on the charging battery now. 8 amps, 50 volts, 225 volts here. Now these lights are not quite full brightness. But they are very bright. I can show that here. Let's take another quick look. Still picking up speed. And I could push it harder, a lot harder. But let's turn on some lights here. I got some pretty bright lights on right now. You can get a look here now. I've got no lights on in the room, just these bright LEDs. I want to say they're at about half brightness. No, not even quite half brightness, but they're still pretty bright. So we're at 250 volts. So really we're going 50 volts across each diode module. So I'm kind of blinded here. I can't really see what I'm doing after looking at those lights. It's hard to see with video how bright this thing is. But anyway, again, we're charging these batteries here. These are the interstate batteries, like I said, and they're at 48 volts. You can see they're at 56 volts now. And again, we're only at 49 volts from the input batteries over here. So we haven't dropped very much. So what we want to do again is continually check temperatures when we are just starting. We can look right now and we're 68 is here, and transistors are still pretty much at room temperature. Now we have a little bit more airflow blowing here against the control circuits. So let's look at some of these. These resistors here are cool. This one's pretty hot right now. And of course, we've got the halogen bulb there. So I was just showing this one light on to show you the different kinds of loads that you can run on the trigger coil here. And we were running that pretty much at full brightness, and that is 100 watts worth to make that full brightness, as I said. So again, now we're running an actual load here. We can disconnect it to show the RPM difference as we I'm going to have to do it like this. So we can see the voltage. You can see it picks up speed. So this is a load on this motor. It's not too much of a load. It can handle quite a bit more. So we're at 500 volts on combined voltage on these coils here, but we're only, like I said, pushing 9 amps right now. Voltage still climbing, pretty high now. We could drop it down to a 15 ohm resistor here. I do have, or what we could do is remove those 4 ohm resistors there. So let's try this first. So we got a 15 ohm resistor here. Of course, it's always hard to just get rid of the pot right now. We don't need that. Alright, so I'm going to disconnect this quickly. So that's pretty hot. So now we're up to 11 and a half or so. See, this was getting really hot, so we want a different pot there, or a 250. Don't want to burn out that. So you can see we're at 57 volts charging right now, and we're going to be climbing faster with the generator coils again. So we can push this, like I said, we're barely tickling this. What we can do is run each of these trigger wires into its own path here to the trigger wire, and not put so much on this one resistor here, and then or just connect it up to this bulb here. And then we can push each board to, let's see, we're going to say one transistor can do 3 amps at 48 volts. You have to be very careful with it when you're doing that. Have enough cooling on the heatsink, because that heatsink is going to get fairly hot, especially a smaller one like this. But right now, like I said, we're barely touching, 1 amp, just over 1 amp per board, 1/8 on the transistors. So we want to run the transistors usually at least a quarter amp to an amp is a good operating range for them. Like I said, you can take them higher. And they can produce a lot of heat if you want the heat. So there we go. We're again charging pretty high. I'm sure this resistor is getting nice and toasty. So now we can go over here and take a 10 ohm resistor and go higher. Don't want to do this too low on here. Still hot. So let's see if we can still push it higher with this set of resistors. It may, sometimes they bog down, but we have a long way to go before it slows down when we put the, so now you can see the light coming on the halogen bulb, because we've come to a lower spot here. So now we've got really full brightness going here with the lights. These are very, very bright. I'm not even looking at them and it's blinding me. It's being hard to actually see. So I wouldn't want to go too much further on these bulbs here without putting more in series, which I have a lot of them, because you don't want to go over. They're rated for around 30 to 40 volts. I think I've got, this one is for, yeah, 32 to 36 volts for this glow light that we were looking at earlier. So they're around that voltage, and right now we're hitting them with over 50 volts each, so that's not too good to do, but I wanted to show something practical. This is a lot of light. I could separate them, but I want to make them neat because people are complaining of a rat's nest of wires that I have here. So, but anyway, you can get the idea with the way these resistors work. These ones are still cold. Actually, these ones are starting to get a little warm, so now they're kind of sharing the load a little bit. And of course, so we've got some power going here. So at 15, almost 16 amps, we are almost at 60 volts, well, 59 volts on the charging battery. Again, this battery hasn't been really cycled very much, but this is getting very hot. So it really needs to be charged and discharged and conditioned more and more to be charging faster. And like I said, we really want a battery bank 10 times the size of this for optimum performance output, because we're really bottlenecking the system. And I should be using bigger wire, but since I'm only pushing relatively small, not very hard, then I'm not worried about that right now. We have bigger wire for bigger batteries. So we'll try and get some forklift batteries in here and show that soon, charging up as soon as we get some rejuvenated. And unless somebody wants to donate some. Always taking donations if anybody wants to offer. But anyway, that should do it. I think what I'll do, we'll watch it go up a little bit more here, and then I'll turn it off. Anything more I should say here? Let's see. Oh, this one's missing one bolt here. I gotta still put in. And I've already covered the last video, some of the details. You can look at these three videos together, the 4-pole and these two 10-pole videos, and you'll get the whole picture if you look at all of them and you pay attention to detail. So, yeah, again, we're almost at 60 volts here. And now what we're going to do is turn it off. So again, this is my on and off switch here, so we can watch all the voltages here if you want, and the lights. So you can see, there is no amp draw anymore, of course. You can see the bulbs are dimming as the RPM slows down. Let's see the other one. So So yeah, you're gonna have vibration because of the magnetic lock taking place there at the lower RPM. So for this motor, it wants a little speed. I guess I never did run the RPM. Never measured that yet on this. I could have done that, but I'm just gonna let the video be finished here for now. And if we want to see the maximum RPM, we're gonna really take this up with some big batteries and all that. So you can see how long it takes to actually shut down. So there you go. There's the magnetic. Still 34 volts on the generator coils. So again, we can lower speeds have, now that was 500 volts plus combined with the load on it. Without the load, the open voltage was easily 500 volts on, or 1000 volts combined when we get up there at maybe 20 amps or so on input. So like I said, we can push comfortably 80, 160, even 240 amps on the input. Maximum I would take this at 48 volts would be 240 amps, but you better make sure everything's really well connected. All your wires are very, very well connected, and there's no mistakes anywhere. When you're, tickling it like we're doing here at 1/8 of an amp each transistor, then there's not much to worry about. So you can see the battery voltage on the input has bounced pretty much right back to where it was when we started. And I mean, it will come back 50.4, I think is what we started with. And, or no, 50.9, sorry. And the other one will come back down, but it will be higher. Obviously, we ran this for a while. Looks like I've got 23 minutes on this video, so we ran it for at least 20 minutes. Yeah, so there you have it. You have your load here. You have a load here. A lot of heat loss, and like I showed, you can run lights. This light right here alone is worth 100 watts, even at the low. So we could combine 10 of those right here on the trigger resistance and have 1,000 watts of light there, another 1,000 watts of light easily on the generator coils. And then we have battery charging. The more batteries we charge, like I said, we can run, we've got the minimum 50 volts, because if you have 50 volts input, you need to have 50 volts output. You don't want to go under that. And then you could easily do 100 volts or 300 volts on the output, or 600 volts one customer wants to do. So yeah, again, you just want to be careful that everything's well connected. You don't have batteries that are shorted or bad connections on your wires or in the battery itself. You don't want to really use this to rejuvenate batteries when you're really pushing it. If you're going to rejuvenate a battery bank, be safe with 12 volts, I would say you'd want to do, because you're safer at 12 volts input. I'm talking about, you could charge higher voltage output, but on the input, when you're dealing with bad batteries, you don't want to make sure they're not really, really bad, because it will not see a load and it will blow it out. So, like I said, these are Golf Car 2 20 amp hour batteries here, 225, I believe they're about the same. And they, like I said, the load that you want to really push with this system is at least on the charging of from the motor coils, that kind of load, you want to have a big bank. If you want to use the same kind of setup with the generator coils, you can have no problem using these types of batteries, smaller batteries, because it's a different kind of output. But this kind of output that we're dealing with here wants a bigger load. Like I said, you can do higher voltage or capacity. So, your golf car or your forklift battery would be 1,000. Anywhere between 500 to 3,000 amp hour batteries. Big cell phone tower batteries, the solar batteries. Those are all what the system is made for. And we don't have any of those right now. We will in the near future to show that. But anyway, we've shown that kind of thing in the past with the big batteries. So it's all the same. All right, so I think, we've watched the batteries are, stabilizing here. And I don't think I'll call this quits here, but like I said, I'll let this sit for a couple of days and see where it, stabilizes to for my own purposes. But the batteries, like I said, this one will come back to 50.9 or maybe 50.8. This one, right, these batteries here, like this. So we started 50.9, and then this one will be higher than it was. What was that? 50 point. I forget now. Was it 50.4 or whatever initially, and then. But anyway, it will be higher than what we started combined. So, and like I said, it's not that I'm trying to prove from this simple test anything to anybody here. It's just I'm just giving a basic explanation of what to expect under these circumstances. So, like I said, if we wanted to get more output out of the system, we would have bigger batteries being charged, higher voltages, and a good rule of thumb would be 4 times the input capacity, double the voltage, 4 times the input capacity. So that would be 8 times. So that is ideal. I mean, ideal would be really ideal would be way bigger than that too, but it's not practical for people to do that. But anyway, that's just what I'm saying. There's a lot of different things that could be done, like we talked about, giving rest periods to the batteries. The batteries are still charging right now and will be for a while, and you can observe that by doing these kind of tests where you run it, you stop it, and then you run it again. Run it for 5 minutes, stop it for 5 minutes, and run it like that for a while, in cycles, and see the difference between just running it constantly. And you'll see overall you'll get more out of it. So ideally, again, another ideal would be swapping around battery banks. As long as the motor's turned off, like that switch right here is turned off while you change loads. That's important. So, like I said, rest periods, keeping the batteries close grouped together. It's better to actually have batteries that are higher voltage. I'm just talking about something else I don't need to mention right now. But anyway, there's a number of things we've talked about over the years that can improve the output. There's really no end to it. There's so many different things that can be done. So that's it. This is the basic setup, still, as we call it. there's a few things that are that are a little bit more advanced that we talked about, but this setup right here with the capacitor pulsar does not come with a kit. I'm going to start selling the SCRs here on the website. I've got actually some bigger ones. That's an 80 amp, but we actually have 110 amp ones that will begin to sell for around $50 or so. And then I think we'll sell some big bridge rectifiers too. I've got 140 amp ones, I think, that we sell, and you can use those for the, converting the AC to the DC on these generator coil outputs. And like I said, what you can do is you can run the wires in parallel. I've just, and I can show you right here, again, what we've done. We've just seriesed them all up here on both sides. Just so you know, there's nothing strange or hidden underneath here. So we've just done that. And again, these wires are for the opto. And so one last look underneath here, so you know there's nothing fishy going on underneath here. I don't ever play any games or tricks with these motors. If they make a mistake, then I make a mistake, but we're still looking at these voltages rising and falling. And like I said before, you can look at the total combined voltages across. Let's see if I can show that. Okay, so this is... Okay, so we're going to look at this one over... Let's look at the combined voltages, which is helpful if you want to remember where you started and where you ended. No, looking at the wrong one here. So that is